glad to talk about SimpleTrack, which analyzed 3D MOT and proposed some very simple yet effective improvements. And I'm happy to see that many of the improvements are actually adopted by some recent 3D MOT works. So our paper makes the following contributions. First, we summarize a tracking by detection framework. Then we analyze some failure case and then propose some effective solutions. And finally, we also rethink some existing benchmarks so that every researcher can compare fairly to each other. So in case you are not familiar, I want to give a visualization about 3D MOT. So 3D MOT wants to track objects coherently over time. That includes both localization and also identification. And a general tracking by detection framework is we want to associate the detection bounding boxes to the old tracklets on every frame. And that is to say, we want to use some association matrix to link every detection bounding box to every motion prediction of the tracks. And then we can use the bounding boxes to update the states of the tracks. So the first failure case we noticed is related to how we pre-process the detection bounding boxes. So with the key insight is that there is a difference between object detection and multi-object tracking. Because object detection wants to maximize the MAP, they generally have to output many redundant bounding boxes just to improve the recall. And however, this will confuse the trackers. Then we propose to remove the redundant bounding boxes via more regressive NMS. And compared to score filtering, this more aggressive NMS is even better because it can keep the spatial diversity of the bounding boxes. And the second part we focus on is how we can do better association. So previously, when people do association, they can use some association matrix such as IOU or L2 distance. However, if we use IOU, it is not flexible enough. If this frame rate is really low and the agent is moving abruptly, the IOU may lose target. However, if we use L2 distance, it is now discriminative enough to be aware of, for example, the orientation. And in that case, they may associate this false positive detection B to the motion prediction, the blue bounding boxes, instead of the true positive A. So to overcome the disadvantages of the association matrix, we propose to use GLU, generalized IOU, which combine the best of two worlds and can be better than both of the methods. And then the final part is about how we can do lifecycle management. So lifecycle management means how we can determine if a track is alive or dead. So most of the works, they focus on better association because they think this is the main source of ID switch. However, we after doing some data analysis, we find out that the early termination consumes more than 90% of the ID switches, which is really surprising. So early termination here means that we have a track, we initially assign it to A, but then we terminate and then it switched to ID B. So that's one ID switch. So to avoid this thing from happening, we can use low score detection bounding box to indicate the existence of an object. That is to say, if there is a low score bounding box corresponding to a track, we don't have to output that bounding box, but we have to keep that track alive. And this thing is called two-stage association, and it really improves the performance. And finally, if you look at the performance on Waymo Open Dataset and Nuisance, our method is really competitive compared to some related methods. And this proves that our solutions are simple yet effective. And finally, we want to talk about some rethinking of the benchmark. But because of time, I will only briefly mention that. The first is to use higher frame rates. And the second is to output motion model predictions and assign low scores. So these two will give you better tracking result and also fits better to the A-multi evaluation. And finally, here are some summary of SimpleTrack. If you feel interested or want to contribute to the open source code, please feel free to contact me. Thank you.